Hello guys, it's a beautiful day once again to see your faces online. Now, if you've ever had problem with something called Archimedes principle of flotation, it shall be addressed in this video. We have many aspects of physics that we shall be touching in this section. Don't forget that I am Tutor Dami. We shall be looking at Waec Physics 2015, question number 1 to number 5, and we shall be bastardizing Waec. Now, don't forget that if you learn something from this series, click on the like button. We have loads of content to send to you that will better help you understand physics. Let's get to number 1 now. Number 1 says, which of the following statements about mass and weight are correct? You know about mass and weight, right? You were taught in year 1, right? Now, what is correct? Number 1, mass is the force of gravity on the body. Is that true? 2, the mass of a body is the quantity of matter in the body. Is that true? 3, the weight of a body is greater at the equator. Is that true? 4, the mass of a body is greater at the pole. Is that true? Do you have any idea which of them is true? Now, let's take a look at it now. Now, first of all, the definitions are true. The mass is the measure of number of atoms or amount of matter in an object. That makes option 2 correct. The mass is the quantity of matter in an object. So that means number II is correct. Mass is the amount of matter in an object. Then number 2, weight is a force exerted by an object of fixed mass due to gravity. That makes option 1 true. Weight is the force of gravity on the body. It is correct. So 1 and 2 are automatically correct by definition. So weight is the amount of gravitational force acting on the body, while mass is the amount of matter inside the body, and that is the definition of mass and weight. Okay, now let's check out the next one. Mass is a constant. That means mass does not change. That makes option 4 wrong. The mass of a body is greater. It does not get greater. The mass of a body is fixed. That means the mass of a chicken in the market is fixed. That means if you take the chicken and you measure the mass now, and you measure the mass tomorrow, and you measure the mass at any different place or at any different time, the mass will remain the same. The mass of people don't change. Like the mass of my body remains the same. I can grow, but my mass at different places around the world, unlike weight. If you take me to Mars and you take me to the Earth, if you take me to London, you take me to different places, my mass will remain the same. So mass does not change. Okay, now that's mass. So that means option 4 is wrong. Remember that option 1 and 2 are correct. Now let's check out number 3. Option 3. Then it is not weight is not constant. That means weight changes, right? Then it is measured with a spring balance. That's another difference. We measure weight with a spring balance, but we measure mass with a beam balance or a chemical balance. Now the SI unit of mass is kilogram and weight is Newton. So, but generally option 3 is wrong because the weight of a body is greatest at the equator is super wrong. The weight of a body is rather greater at the pole. So the correct option is simply the weight is the force of gravity on the body, and the mass of the body is the quantity of matter in the body. Full stop. And that is the answer to number 1. That makes option A correct. 1 and 2 are correct. Let's take number 2. Material that can be stretched. When you hear the word stretch, you should know the answer. That's just straightforward. Material that can be stretched, when you stretch something and still return to its original form when the stress are removed, is said to be what? Is it elastic, elastoma, or what's even elastoma? Plastic or thermoplastic? Now the answer is just elastic. You can see this is a rubber. Anything that can be stretched and that if you release it, it will return back to normal is said to be elastic, and that is the answer. You know, there are some people that when they have trousers, they get into the trouser. When they get in, they don't put belts, because the band of the trouser is elastic. So if it is elastic, you might choose not to put on belt. Just put on the trouser and move, because it is elastic. That means it can expand and contract back on its own. It will return back to its normal shape. It is elastic, and that's the kind of trouser we wear in the olden days. Okay, so that's number 2. The answer is simply elastic. Number 3, which of the following unit is derived? You know, we have in the beginning of physics, we were taught fundamental quantities and derived quantities. The fundamental quantities are the main quantities that cannot be formed, while derived are formed from the fundamental quantities, right? Now which one is derived? Now, kilogram is from mass. It can't be formed by anything. Mass is a fundamental quantity. It is on its own. It is a master. It can't be formed from anything. Mass is a fundamental. So kilogram is for mass. It can't be formed from any other thing. Then length is for meter. Length is also a fundamental quantity in physics. It cannot be derived from any other formula. Length is length, and its unit is meter. So meter is also fundamental unit. Then temperature is Kelvin. Kelvin is temperature. So the fundamental quantity of Kelvin is temperature. While Kelvin is the unit of temperature. That means Kelvin is the fundamental unit of the fundamental quantity temperature. So, and they are all fundamental. That means they cannot be made from any other formula but themselves. Okay, but Newton is for force, and force can be derived from mass and acceleration. So that means Newton is for force. Force can be made. Force formula. Force as a formula. It's not fundamental. It's not a beginner. It was made. Force is created from mass times acceleration. Where mass is kilogram, acceleration is meter per second square. Then that is also called, this is the unit of force. It is also called, this unit is called kilogram meter per second square. It can also be called, in simple language, Newton. That means Newton is not a fundamental quantity, and Newton is the criminal we are looking for. So Newton is D. D is not fundamental. Kilogram is a fundamental quantity for mass. Meter is for length. Kelvin is for temperature. But Newton is for force. It is not fundamental. It is derived, and that's the answer. Now, number four says the barometric reading at a place 73.5 centimeter mercury. Calculate the pressure at the point 30 meters below the surface of the water contained in the reservoir at a place. Now we are given G is equals to 10 meters per second square. Density, that G is acceleration due to gravity. Density of mercury is 1.3 times 10 to the power 4 kilogram meter per second per meter cube. Then density of water is 1 times 10 to the power 3 kilogram meter cube. Now we are told to find what? We are told to find calculate the pressure. Now you know this is a what you can see here is density, different densities. You can also see meter, that's height, meter, and you can also see all you can see is just density and then height. Then you can see G also. Now that, and we are told to find pressure, right? Now if you always think that pressure is force over area, think twice. Pressure is not only force over area. Pressure has two formulas in physics. One, the one that is most popular is pressure is force over area. But there's another one that is called density times height times gravity. So pressure can be expressed in two ways. You must know that pressure is naturally force over area. That's the first formula of pressure. But pressure can also be called as density times height times gravity, and that's the one that will come to play here. Now the density of that substance, okay, is 1 times 10 to the power 3 kilogram per meter cube, and that's what you have here. 1 times 10 to the power 3 kilogram per meter cube, and that's the density of water, right? You know, we are talking about water, right? Now I did not use the density of mercury. Please take note of that. And I did not use the density of the place, okay, 73.5. I only use the density of water. Why? Because we are talking about water, so the rest are traps. Watch out very well. Now next thing I did was that I talked about height, because the formula says height. Height is 30 centimeter because it was said at a point 30 centimeter below the surface of the water. So it is 30 centimeter, right? That's the height. Then I spoke about gravity. Gravity is always 10 meters per second square. There should be a square here actually. So it is 10 meters per second square. That is the acceleration due to gravity, right? Now multiply, put them into the formula. So plug these terms into the formula. That will become 1 times 10 to the power 3. That's my density. It's actually the same thing as 10 to the power 3. That's 10 to the power 3. 1 is nothing. Times, then the height is 30 meters. That's times 30. Then the gravity or the acceleration due to gravity is 10, and that's 10. Multiply this. That will come 10 raised to the power 3 times 10 is 10 to the power 4. Then 30 times 10 to the power 4. This 10 will multiply this 10, and that will give me 10 to the power 4. 30 times 10 to the power 4, and that will give me in standard form. You will move this point from here, you will move this way, and that will give me 3 only. You will move from here to this place, that will give me 3 only times 10 to the power 5. Because this 0, this 10 here will add up to this 4. That will become 10 to the power 5 Newton meter square. And that is my answer for my pressure. 3 times 10 to the power 5 Newton meter square. Don't forget the formula that density is also, pressure is also density times I times gravity. And that is the answer. That is the formula for this question. And that is the answer. Option B is the correct answer. Let's go to number 5. An object floats in a liquid when it displays in what? This is a little bit wrong. An object floats in a liquid when it displaces. Okay, in what? Is it in volume of liquid in which it floats, or mass of fluid in which it floats, or weight of fluid in which it floats, or density of fluid in which it floats? Do you have any idea which one is correct? So what makes object float? Is it when it has displaced the volume of liquid in which it floats, or mass, or weight, or density? Any idea? Now let's check it out. This is called the principle of flotation. Now it says when an object displays a weight of water equal to its own weight, see, notice weight, it floats. So what makes things float? Now look at this one. This thing sink because it is denser than the water. So it displays. So when you drop this ball in, it went down because the force, the downward force acting on that body is stronger than the up thrust on the water. So that means it could beat the up thrust. So that means the downward force is greater than the upward force. So the body sink. But here, it did not sink because the downward force and the upward force are equal. So it floats. But here, it floats. But here it sank partially because at that point the upward force and the downward force are equal. So here, when it is floating, the upward force is greater than the downward force. So the body can't go down because the force acting up is stronger. It will remain up. Then, but here it stayed in the middle because the upward force and the downward force are equal. But here it sank because the downward force is greater than the upward force. So it sank. Now, the principle of flotation says that something will sink only when it pushes out the weight of liquid that is equal to its own weight. So that the reason why this body sank was because it has pushed out water that is equal to its own weight. So it sent out the water to make him go down. And that's why it sank. And that principle is called the principle of flotation, or the Archimedes principle of flotation. A floating object displays a weight of fluid equal to its own weight. And that is called the principle of flotation. And the answer is it will only sink when the weight of liquid it displays is equal to its own weight. That's weight of liquid in which it floats. Like if you have water in a cup filled to the brim, and you drop something like a solid material, like you drop a pencil inside a cup, the pencil will push out part of the water. The amount of water it pushes out is the weight of the pencil. That's just what we are saying. That's just the principle of flotation. When something is dropped inside a liquid, it will push out the amount of liquid which is equal to its own weight. And that's the principle of flotation. And that it is all about not volume, not mass, not density, but weight. And that is the answer to number 5. So don't forget, if you learn something from this series, to click on like button, because we have more content to send to you that will better help you understand physics. Until we see you again, guys, next time, take care of yourself and bye for now.